Sketch the graph of y equals 3 tan of x minus root 3 for x is an element of negative 2 pi to 2 pi. Clearly label all asymptotes with their equations and axial intercepts with their coordinates. So the first thing I'm going to do is work out what the period of this tangent function is. And the period is equal to pi divided by n, where n is the coefficient of x, so in this case n equals 1. Therefore, it's pi divided by 1, which is just pi. And whenever we're dealing with a tan graph, that's really useful because all key features are exactly one period apart on the graph. So now we can go through and find the key features. So the first thing we're going to find is the y-intercept, and that occurs when x is equal to 0. So y is going to equal 3 times tan of 0 minus root 3. However, tan of 0 is an exact value you should know, and it is 0. Therefore, the y value of the x-intercept is just negative root 3. Next, we're going to find the x-intercepts, and they occur when y is equal to 0. So we're going to solve the equation 0 is equal to 3 times tan of x minus root 3. And when you rearrange that to get tan of x by itself, you'll have tan of x is equal to positive root 3 over 3. And now that's an exact value you should know for tan, so that gives x is equal to pi on 6. So that's going to be one of our x-intercepts in this domain. Next, for the tangent graph, we need to find the asymptotes. And these occur when cos of our angle is equal to 0. And that's because tan of theta is equal to the ratio of sine theta over cos theta. And whenever you divide by 0, you'll get a vertical asymptote on your graph. So solving cos theta equals 0 is the same as cos, and the angle in this expression is just x, so cos of x equals 0. And you should know that that occurs when x is equal to pi on 2. So that's one of the asymptotes on the graph. Finally, we'll also need to know the coordinates of the endpoints. And the first one we'll do is x is equal to minus 2 pi. So that will give us y is equal to 3 times tan of negative 2 pi minus root 3. However, tan of negative 2 pi you should know is 0. Therefore, this is equal to negative root 3 as the y value of that endpoint. The other endpoint occurs at x is equal to positive 2 pi. So we will have y equals 3 times tan of 2 pi minus root 3, and once again tan of 2 pi is 0, which you should know, leaving the y value as 3 times 0 minus root 3, which is just negative root 3. So now that we've found all this information down the right hand side, we can use it to form a graph. So the first thing I'm going to put on is the asymptotes. So we know that the first asymptote occurs at x equals pi on 2, which is somewhere around here. So we draw our asymptote on as a straight vertical line that is dotted, and that is going to have the equation x is equal to pi over 2. To find the other asymptotes, we can simply add or subtract on a period. So if I subtract off a period, that's the same as subtracting off 2 pi over 2, because the period was found up here to be pi. So the next asymptote, which is going to be here, is going to have an equation of x is equal to negative pi over 2. If we subtract off another period, we subtract off 2 pi over 2, and that will give us x is equal to minus 3 pi over 2. So that will give us an asymptote here. And if you were to attempt subtracting off another period, you would find x is equal to minus 5 pi over 2, which is outside the domain. So there's no more periods in that direction. So instead we're going to add on a period to this asymptote, which is the same as adding on 2 pi over 2. And that gives us x is equal to 3 pi over 2. And again, if you were to attempt to add on a period, you would get to 5 pi on 2, which is outside the domain. So that is the last asymptote. And again, we draw that on as a straight vertical line that's dotted. So now that we've got our asymptotes, we know that our tan graph simply sits between them, and that it has been translated root 3 units in the negative y direction. So that means that our graph is going to look like that. And it's going to have the same shape between the next set of asymptotes. and the same shape in here. So now that we have the basic shape of the graph, we can start to label the key features of the graph. So this x-intercept here was at pi on 6 as an x value and y is 0. And this y-intercept was found to be 0, negative root 3. Now that y-intercept actually turns out to be an inflection point on the graph. So that's another key feature that we're going to label on this graph. Now to get the other x-intercepts here and here, what we're going to do is we're just going to add or subtract off the period from the x-intercept we already have. So if we add the period, which could be written as 6 pi on 6, we're going to have pi on 6 plus 6 pi on 6, and that gives us another x-intercept at 7 pi on 6, 0. Now if you were to attempt adding another period on, you'd find that the x value would be 13 pi on 6, which would be outside the domain of this graph. So we don't have to put any more x-intercepts in the positive direction. So instead we turn our attention to the negative direction. So we take our pi on 6 value and we're going to subtract off the period. So the x value is going to be pi on 6 minus 6 pi on 6 is minus 5 pi on 6, 0. And if you were to subtract the period again, you'd find that there is one more x-intercept inside this domain, which would be at negative 11 pi on 6, 0. So that means our graph would come down through here, have an x-intercept, and then end. And that would be our endpoint at negative 2 pi. And then back over this side, because we're not quite at x is 2 pi yet, we know that there's going to be part of the graph that's going to come up and end at negative root 3. This endpoint here is at negative 2 pi, negative root 3, and we found the value of that endpoint on the right hand side over here. This endpoint here is at positive 2 pi and a y value of negative root 3 still. And then as I mentioned earlier, we're also going to label on the points of inflection. So there's a point of inflection here and a point of inflection here. And this value is going to be one period away from the previous point of inflection. So this is going to be negative pi, negative root 3. And this is going to be positive pi, negative root 3. So that's the fully complete graph for y equals 3 tan of x minus root 3. However, it's a little bit messy to read. So what we've done is got a computer to generate the same graph and label all the key features for us, and you'll notice that all the key features have the same values as what we found on the previous slide. This is just a neater representation for you to consider.